Although you might think that astronomers and astrophysicists only do research, sometimes this is not the case. All positions usually require doing extra work besides research, like teaching or supporting functional work for a mission. This functional work can include things like developing instruments, working on the design of a detector, and defining and writing algorithms for calibration of data. Some of these technical positions are filled by astronomers with a PhD, which also might get some time to do research, while others are filled by physicists or astronomy graduates who decide to start working as soon as they finish with their bachelor's degree and learn more about instrumentation, software development for missions, and another research areas. This is also an opportunity for some people to figure out if they want to pursue a doctorate in astronomy or continue their studies in another technical related field. For bachelor's graduates, these jobs are full-time doing technical work, although this technical work might also include doing some research with the scientists working on those missions. There is nothing wrong with any of these choices, and many of the people who I have talked to, they are very happy with the decisions they made. Here I will give you examples of the kind of technical work that 4 colleagues working at the Space Telescope Science Institute do, each with different background and also doing different work. First, let's talk about Dr. Emily Rickman. She's from England and she's an astronomer and a science operations scientist working for the European Space Agency at SDSCI in Baltimore, Maryland. Emily has a PhD and does very cool science in exoplanets and brown dwarfs. However, she also works at least half of her time supporting the Space Telescope Imaging Spectrograph, or STS, and in here she talks about the current projects she's working on.
Yeah, so this is mostly about updates of STS on the Hubble Space Telescope. And so our biggest updates we have available are some new Jupiter notebooks that we have available on the Space Telescope GitHub, available next week. The 3 most recent ones have been created by our intern Kay Ding, who is a Hopkins grad student. So one of them is on customizing CCD reference files using the refs Python package that we see. We also have a notebook available on target acquisition, testing different cases of success and failure cases of target acquisition. You can see here different cases of successful target acquisition, also the delayed guide star acquisition, as well as saturation and dealing with multiple sources in a single acquisition. We're also developing a monitor to track cosmic ray flagging in CCD spectra. And then the final thing that I'll highlight from this poster is the exposure time calculator for Hubble. We'll be using the new Pangaea-based exposure time calculator, which is the same basis of the JWST exposure time calculator. It's currently in an alpha release, so we don't encourage you to use it for HST cycle 31. Try it out, test it, and if you run into any issues or any problems, we want people to report it so that we collect all of those bugs.
Next, let's talk about Daniel Stapleton. He has a bachelor's in astronomy and physics from the University of Maryland, and he has been working at SDSCI for over a year now. While in college, he worked processing data of regions around young stars in the Small Magellanic Cloud, taken with the Spitzer Space Telescope. Now he works as a science support analyst, spending almost all his time working for the STS team. Here he talks about the work he's doing now.
So I'm on the STS instrument of the Hubble Space Telescope, and what we're interested for STS, because it is the oldest instrument on the Hubble Space Telescope in particular, is looking at the sensitivity of the instrument in time. And this sensitivity can change depending on what mode of the instrument you're using. So the instrument is composed of 3 different detectors, the NdV MUMA, the FeV MUMA, and the CCD. And each of these detectors has different gratings. Each grading corresponds to a certain mode. So for example, G140L would be low mode grading, and G140M would be a medium resolution grading. And so essentially each of these individual gratings is monitored by an individual standard star, one standard star. So what we do is, when we're looking at the time-dependent sensitivity, is we look at how the throughput, or the sort of what the instrument's collecting, how that changes in time. So it could be degrading, it could be improving. And because we only use 1 star for each of these modes, one of the interests that we had was whether or not there's some variability in these stars that would be throwing off our time-dependent sensitivity corrections. So for example, let's say the star's brightness happened to increase suddenly, then you would see an increase in the time-dependent sensitivity, which wouldn't be real, it wouldn't be part of the issue. So what we did was we grabbed another set of standard stars. These are what we call the triad standard stars, GG71, GG153, and G191b2b. And by observing these stars, taking these stars' data and comparing them with the trends that we get from the single standard stars, we essentially want to show that the corrections that we get can be reproduced. And what we find in each of these plots, which I can show here, an example TDS plot would be this. So we have the relative count rate, which is normalized by 1, which is the very start of the detector. That's when we turned it up. And any changes after that deviate from 1 percentage points. So the red trend is the calibration pipeline. That's what we adopted from the original standard star. And the red range is the promised agreement with the trend. And what we show here is that data aligns well with the trend. And we essentially show that the SIS instrument, which is actually the basis for the flux calibrations of all the other Hubble instruments, as well as the TDS instruments, is okay from the TDS side of things, which was a very happy thing to see.
Sierra Gomez is also a science support analyst at STSCI working with another spectrograph on board of HST, the Cosmic Origins Spectrograph, or COS. She obtained her bachelor's in astronomy and physics in 2022 at the University of Massachusetts, where she was involved in several research projects like taking images of T Tauri stars and spectroscopic observations of accreting brown dwarfs. Sierra now supports the COS team, although she's still considering going back to school and pursuing her doctorate in astronomy. But for now, she's enjoying the work she does for COS, and she talks about it.
Yeah, so my poster's about updated or new updates for the COS instrument on Hubble. So we have a few new recommendations. We have a few COS recommendations for G160M LP6. Additionally, we have a new gain stack table that's going to be delivered. And it's mostly changing the data for FUV. And then we also have a new TDS time-dependent sensitivity table being updated with new breakpoints. As time goes on, we'll increase throughput for the detector, so there's just be a few flux adjustments for that. Along with that will be the updated flux photometry table.
Finally, Dr. Javier Sanchez, he's from Lorca, Spain, and he's an associate astronomer for the European Space Agency, also working at STSCI. Javier's research expertise focuses in observational cosmology, trying to find or figure out quite interesting things about dark energy. His functional work is with a team supporting the Science Operations Center for the Future Nancy Grace Roman Space Telescope, or ROMAN for short. Here he talks about some of the work the team is doing now.
Roman Science Operations Center, based on Space Telescope. Basically, at the Science Operations Center, we are in charge of the processing of the imaging data from Roman. The particularity is that the image is a big flow of images, about 200 times larger than Hubble recently, and there's like two sorts of surveys, and there's so-called continuity surveys, where 75% of the time will be, and 25% of the time will be open to the community. There is a process going on right now to basically define these core community surveys. So people are encouraged to send their ideas. Have a conference coming up on the virtual restrictions to open. So we also have a newsletter that just came out. So check it out. There's new application as well for Roman and distribution tools.
As you can see, there are many things that you can do with an astronomy degree. It is not only about research, but also probably involved in a very important and cool mission.